Good evening, friends. Study with Apala. In chapter 7, structural feature of a rock. Physiographic evidence. Some physiographic features may serve as indirect evidence of fault. Amongst them, the most important are elegant springs. In some regions, a number of springs may occur along the base of a slope, almost in the same lines. The existence of a fault along the spring line is strongly suggested. Offset streams. Sometimes streams may show an interruptions of or offset or break in their profiles at some places. The offset in the course of a streams is among the possible effect of faulting and should be taken as an evidence for the same. Causes of faulting. So look here. Faulting are generally caused under the influence of stresses acting upon the rock of the crust of the earth from within. Any rock or on or below the crust may withstand all the operating stresses up to a limit which depends upon its cohesive strength and internal frictions. But when that limit is crossed by the operations stress, the rock yields by fracturing or breaking along certain directions immediately for or even gradually after the development of these features. The blocks created along the fracture surface sudden or gradual displacement along those fractures under the influence of the same or different stresses that cause the fracturing of the rocks at the first place. The displacement may take place essentially along the fracture surface or in different directions and for different distances depending upon the magnitude of the operating stresses, thus the giving rise to different type of fault. So in figure, relationship between principal stress and type of faultings. Maximum principal stress in lambda 1 is vertical. B intermediate principal stress lambda 2 is vertical. C list principal stress lambda 3 is vertical. So lambda 1, lambda 2, lambda 3, here in lambda 2, lambda 3, lambda 3, lambda 2. In a highly or oversimplified situation, the type of fault likely to form is related to a stress field operating in a given area. Thus, the talking in terms of the three principles stress, normal fault would forms when lambda 1 the maximum stress is vertical. Similarly, strike slip fault from when lambda 2 the intermediate stress is vertical, and reverse or thrust fault forms is the situations were in the stress field the maximum stress direction, that is lambda 3, is come to occupy the vertical directions. In also these idealized situation, it is assumed that the rocks are isotropic in characters and the more Columbus laws of rock failures holds good in those cases. As to the source of these forces that are responsible for causing faults of great dimensions in the crust, in many cases even for several hundreds kilometers, it may be said that this has been one of the most baffling problem in geology. Many theories were put forward and supported by many and opposed by others. According to one's view, the shrinkage experienced by the crust of the earth due to its gradual cooling from an original hot molten state is primarily responsible for the tension developing in the crust. Another view is that hot molten material existing below the surface of the earth is in a state of movement governed principally by convections current. These currents are created due to the flow of heat from the lower hotter part of the earth and partially from the radioactive sources. What is relevant here about the convection current is that they exert a dragging effect at a place below below. What is relevant here about the convections current is that they exert dragging effect at a place below the crust where they diverge, causing tension and compressive effect at other places where the current happen to converge. This gives rise to stress of different kinds that are ultimately responsible for throwing the rocks above into fold and fault of a great variety. Thank you.